example 5 here in lesson 1-1, and we're going to focus on finding the average rate of change on the parabola h of x equals x squared over these three intervals, from -2 to 0, from 0 to 3, and from -2 to +3. So we actually have 3 tasks to do for one problem. So there's like 3 sub-problems here. If you're watching this from home for the first time on video, I just have the formulas for you at the top filled in. So if you want to pause it and write those down and then restart it, that's up to you. All right, here we go. Step 1. Let's go ahead and pop h of x, or y, equals x squared in the graphing calculator now. So this is what the parabola h of x. H of x is just sort of a fancy symbol for y. Function notation, we'll talk more about that this year, equals x squared. It's your standard parabola centered at 0, 0, and going to 1, 1, 2, 4, 3, 9, because every x gets squared to produce the y. It has symmetry because when you square a positive, it has sort of a twin point on the other side of the y-axis, like 3, 9 and -3, 9, because they produce the same result, +3 squared and -3 squared. Now, back to the problem that we were working on. Let's start by finding the average rate of change from -2 to 0. Let me explain what that means right on my calculator. So, from -2 to 0 means that they want you to have one point at -2, something, and a second point at 0, something, and then they want you to find the slope between those 2 points. Okay? So what we need to do is use our left boundary, -2, and figure out what y is on this graph. And you could probably guess that it's 4, but if you're not sure, you can hit trace, -2, enter, and it confirms that when -2 is the x, 4 is the y. Then for the right boundary for average rate of change, we want to put in 0 for x, and as we're tracing, you can just type in a number like 0 and hit enter, and it confirms that 0, 0 is the other point on the curve. So on my graph, and you can make a sketch on your paper if you want of this parabola, just like I have here. You want to darken in a point at -2, 4, and another one at 0, 0. And then if you have a straight edge or a steady hand, you can just connect the 2 dots. We want the slope of this line. That's the average rate of change for this function on this interval, -2 to 0. So we're going to find that slope, or the average rate of change, or the slope, n, as you might know it, by doing our y2 minus y1 over x2 minus x1. So let's treat this as point number 1 and this as point number 2. So for y2 minus y1, okay, for y2 minus y1, we're going to take 0 minus 4. That'll be in the numerator. The second y minus the first y, divided by x2, that's the second x, minus x1, which is the first x. So that'll be 0 minus -2. So the numerator is -4. The denominator, I see double negative, 0 minus -2 is +2. So the slope, or the average rate of change between those 2 points, is -2. That's the answer to the first part of that problem. And if you look, I think it's believable that this slope has a negative value because it's going downhill, but it's dropping 2 blocks for every one that you go over, down 2, over 1. So that makes sense to me that that is the slope of the line, that is the average rate of change. So back to my note sheet, I'm going to say from -2 to 0, the average rate of change is -2. So I have the problem set up to do the second part of example 5, part 3. So they wanted me to now find the average rate of change from 0 to 3. And as you can see, I have some notes up here for you if you're watching from home. Well, you're all watching from home if you're watching this later. Okay, and what we need to do is figure out if 0 is my starting point. If 0 is my starting point, what's the y that goes with it? Well, if I put 0 in for x, I get 0 for y, right there on the curve. So the first point is going to be 0, 0. Then you're going to travel along the x's until you get to 3. So let's plug 3 into the equation. 3 squared is 9. So as we go from 0, 0 up to 3, 9, well, this graph curves. You can't really find the slope of a curved line or curved curve. So what you do is you connect the starting point with the ending point with a straight line, and you find the slope of that line. So we're going to proceed with finding the slope by doing y2 minus y1 over x2 minus x1. Let me label everything over here. Point 1, x. Point 1, y. This is point 2's x. This is point number 2's y. So the numerator will be 9 minus 0. The denominator will be 3 minus 0. That's 9 over 3. So the slope is positive 3. This makes sense compared to the last one. The last one was downhill, so the slope was negative. This one's uphill, so the slope is positive. The last one's slope was -2. It wasn't as steep. This one is positive 3 because it's steeper than the red line. So back on my answer sheet, I'm going to say that when x goes from 0 to 3, the average rate of change is 3. All right, if you're watching this later, now I'm going to ask you to try the third one from -2 to 3 on your own, and then pause the video right now, and then restart it to check the answer. Here's the work that goes along with the third part. As you can see, we got 1 as our slope. Down here, we just did it an alternate way by reversing the order to prove that the order doesn't matter. So here we go, wrap it up. The average rate of change when x goes from -2 to 3 is